For centuries, the standard view of the cosmos was straightforward. Space was an empty, unchanging stage, and gravity was simply an invisible tether pulling objects toward one another. That changed when Einstein proposed a different model. Instead of an empty stage, space and time form a flexible grid that physically warps and stretches whenever you introduce mass or energy. This wasn't just a metaphor. Einstein's equations showed that because this grid is constantly reacting to the matter inside it, it cannot remain perfectly static. It is inherently dynamic. Gravity acts as the invisible choreographer of the cosmos, dictating the motion of light and the evolving shape of the entire universe. Einstein's math also revealed a hidden variable. Empty space can contain its own intrinsic energy and pressure. While we are familiar with mass creating an inward attractive pull, the pressure stitched into the grid of space behaves differently. If this spatial pressure is uniform and negative, the gravitational effect flips. It generates repulsive gravity, an outward force that violently pushes space apart. This mathematically proven outward force provides the mechanical seed for a reality that extends far beyond a single, isolated volume of space. To understand how that expansion plays out, we have to look at the very early cosmos and a state called the inflaton field. This was a condition permeating space that harbored immense energy and negative pressure. Driven by that intense repulsive gravity, the field caused a burst of super-fast spatial expansion known as inflation. But the inflaton field was subject to the laws of quantum mechanics, meaning it wasn't perfectly uniform. It was constantly shivering with random jitters. Because of those fluctuations, the energy level didn't stay high everywhere. At random locations, those jitters caused the energy to drop, like a ball being knocked off a peak, so it can randomly roll into a lower energy valley. Wherever the energy drops, the super-fast expansion ends. The energy converts into a bath of particles, forming a distinct bubble universe similar to our own. Crucially, the high-energy space surrounding these bubbles doesn't stop. It continues to expand at super-fast speeds. This creates a cosmos resembling a block of Swiss cheese. The solid parts are regions still undergoing rapid inflation, while the holes are bubble universes. The space between them swells so rapidly that the bubbles recede from one another faster than light. Because nothing can bridge that gap, these bubble universes are eternally disconnected from one another. This leaves us with a question: what exactly exists inside those other inaccessible bubbles? Since each bubble is born from a different quantum drop, the fields inside can settle into different resting values. This means the laws of physics themselves can vary from bubble to bubble. You might find a universe with overwhelming magnetic fields, or one with subatomic particles that make the formation of atoms and life impossible. From this perspective, everything we have ever observed is merely one single hole in an eternally expanding cosmic cheese. We are currently trapped in a single bubble, forever blinded by the speed of light from seeing our cosmic neighbors. Yet, using only mathematics and physical insight, humanity has managed to peer through this cosmic veil. The fact that we can map these hidden cosmic structures through logic alone underscores the extraordinary reach of human understanding.